Now let's continue the trigonometric substitution with example 4, 5, and 6 respectively. So you see that in example 4, the function turned out to be more complicated. Okay, you're not gonna see right away that it's gonna be fall into a square minus u square minus a square, or a square plus u square. You may have to work out this one a little bit. Okay, so I'm gonna do that. First, I'm gonna let you simplify. Okay, so we're gonna simplify 3 plus 2x minus x squared by completing the square, Okay, so we're gonna simplify 3 plus 2x minus x squared by the technique in math is called completing the square. The thing that you have is going to be, you have 3 plus 2x minus x squared. You're going to pull out the minus sign. So you would get x squared minus 2x. And you're going to plus or minus 3. Okay, so this is what you will get, this one. And I just pull out the minus sign because I would want the coefficient in front of x squared turn out to be positive number or 1. Okay. In this case, you're going to have to complete the square by, you have x squared minus 2x, and you're going to add by 1 in order to obtain x minus 1 square. So this is the key idea for the thing that I call completing the square. And you add by 1, you would just subtract by 1. Okay, so you see that I add by 1, subtract by 1, and I still have the same term, and you add by 3. Okay, so this is the term that you have. So you're gonna get negative, and you have x minus 1 square, which is the gray term, and you have negative 1. Okay, so you have, sorry, it's minus 3, right? So it's minus 3. I copy the sign wrong. So you get minus 4, right? So you get total equal to minus 4. So this is the blue color here. And you see that if you multiply the negative sign into this one, so it's going to be what? It's going to be 4 minus x minus 1 squared. Okay, so you see that you have 4 minus x minus 1 square, and this one fall into a square minus u square. Okay, so this one you fall into a square minus u square. So you would let, so in this case, you would let a equal to 2 and u equal to x minus 1. Okay, so you have a equal to 2 and u equal to x minus 1. And you have a square minus u square. So you're gonna let x minus 1 equal to 2 sine theta. Okay, let me write this one. So you have u equal to a sine theta. So you have x minus 1 equal to 2 sine theta. And you're gonna differentiate both sides. So you get dx equal to dip side, you get cos theta d theta. Okay, so you get dx equal to cos theta d theta. Ready for you. Okay, so this is how we gonna deal with this guy. So you see that this one change to 1, and you see this term here that I'm gonna highlight, the orange one. So 3 plus 2x minus x squared. You see 3 plus 2x minus x squared turn out to be this orange guy equal to 4 minus x minus 1 square. So that will be my bottom. So it's going to be 4 minus x minus 1 square to the 3 half. And this guy is the orange guy. Okay. And you have dx. You have dx equal to, okay, so you have dx equal to 2 cos theta d theta. Okay, so that my dx. So you get 2 cos theta d theta. So this is how we have this trig sum. However, you need to compute, okay, so you need 4 minus x minus 1 square, and you have x minus 1 is 2 sine theta. So this guy is 4 minus, and you're gonna have 2 sine theta square. So this would allow you to have 4, right? So it's gonna be 4 minus 4 sine square theta, and it's gonna be 4, 1 minus sine square theta, and this would be just 4 cos square. Okay, so it's going to be 4 cos square theta. So you would get integral of 1 over 4 cos square theta to the 3 half, and you get 2 cos theta d theta for the green term. Okay. So this one is the orange term. Okay, so this one, this is what you have, and 4 cos square, and this guy is 4 cos square. So for this, it's gonna be integrate, and it's gonna be 1 over, so you get 4 to the 3 half, and you get cos square theta to the 3 half, and you have 2 cos theta d theta. Okay, and for this guy, you see that, okay, so you see that it's gonna be what, 4 to the 3 half. Let me circle this guy and calculate this guy separately. So I get 4 to the 3 half here. This guy equal to 8, right? So this guy equal to 8. This guy equal to 8. Okay, and this term equal to cos to the third theta. And you have cos to the third cancel with cos, so you get cos square. Okay, so you get cos square theta, and you see that you have this integral, so it's going to be 2 over 8. Okay, so you get 2 over 8, 1 over cos square theta d theta. Okay, so you get 1/4. 1 over cos square is sec square theta d theta. And what is sec square? Sec of integrate sec square, you get tan theta plus c. Okay, so integrate tan is secant. Oh, sorry, integrate secant square is tan. Okay, so you have tan theta. Okay, and you're gonna just draw triangle. Okay, so you see x minus 1. Okay, so you see x minus 1 equal to 2 sine theta. Okay, x minus 1 equal to 2 sine theta. So here you would, so for sine theta, I'm gonna have to divide this space. Okay, let me try to find some space to work with. Okay, so here you're gonna need the final answer in terms of x. Okay, so you need the final answer in terms of x. So you have x minus 1 equal to 2 sine theta. So you're going to use it here. So you have x minus 1 over 2 equal to sine theta. Okay, so you have x minus 1 over 2 equal to sine theta. So sine theta is opposite over hypotenuse. So you're going to draw right triangle and you have x minus 1. So you have theta. So you have x minus 1. I have to write this way. So x minus 1, which is opposite. And you have hypotenuse equal to 2. And the bottom guy is the adjacent. So it's going to be square root 4 minus x minus 1 square. Okay. And so what is 4 minus square root x minus 1 square? This guy is the number that we had before. So this guy is square root of this guy is the orange one that we had before. So this guy is the orange term. So the orange term that I mean is here. See, you trace this one back. So you trace this one back. Hey, it's equal to this one without calculating. Yeah, it's correct. So it's going to be 3 plus 2x minus x squared. Okay, so this is how we have this one. And what will be our final answer? So you need tan theta from this triangle. So for tan theta, it's going to be opposite over adjacent. And the opposite is x minus 1. And the adjacent is the square root 3 plus 2x minus x squared. Okay, so it's 3 plus 2x minus x squared. So for final answer, this guy will be 1/4 x minus 1 over square root 3 plus 2x minus x squared, okay, plus c. Okay, so this is how we have the final answer. So this is number 4 that we have, and everything turned out to be kind of complicated, I know. However, it's gonna be nice and we use whole space on this page. Okay, so be careful on this one. This one is kind of difficult and tricky. Okay, the hard part for this one for my student normally is going to be how would I know to identify A and U? That will be the hard part. Okay, the rest of the part is going to be just easy. If you have this one, you should be able to integrate sec square. Okay, some of my students don't know how to integrate 1 over cos square and 1 over cos square. Keep in mind that it's going to be simple. It is secant square. Okay. The next one, okay, it seems simple. However, for this one, it's not that simple at the end. So it seems simple at the beginning. I'm not gonna argue with that. So for the next one, you're gonna have to integrate from 1.5 to 3 of x squared, so square root 9 minus x squared dx. Okay, so let me step by step with you. The thing that you see is going to be you see 9 minus x squared. So this one will be a squared minus u squared. And you're going to see that it's going to be a equal to 3, u equal to x. Okay, and you're going to substitute u equal to a sine theta. So this is the thing that you normally know. And you're going to have x equal to 3 sine theta. Quite simple. And you're going to need to have x equal to 1.5. Okay, so you get 1.5 equal to 3 sine theta, and you have sine theta equal to 1/2. Okay, so x equal to 3, so you have 3 equal to 3 sine theta, and you have sine theta equal to 1. So you get theta equal to sine theta equal to 1, so it's 90 degrees of pi over 2, and sine theta equal to 1/2, so it's 30 degrees of pi 6. Okay, so this will be two angles that we shall use. Okay, so we now know that from the red guy, it's going to be from pi 6 to pi half. Okay, so we know this one already, and we have x equal to 3 sine theta, so we get 3 sine theta square. Okay, now let me compute 9 minus x squared. So I compute 9 minus x squared, 9 minus x squared. 9 minus x squared will be what? Will be, what will be? So it's going to be 9 minus 3 sine theta square. So it's going to be 9 minus 9 sine theta square. Okay, so this one will be 9 and 1 minus sine square theta. So it's going to be 9 cos square theta. Okay, so that will be my bottom. So it's going to be square root, and this guy will be 9 minus, not 9, 9 cos square. Okay, so that allows you to have this one. After you have this one, you still need to compute dx, and dx will be piece of cake here. So you dip both sides. So you dip side, you get cos. So you get dx is 3 cos theta d theta. Okay, so that is my dx. Okay, so that is my dx. So that my dx. So we have everything ready. So we're gonna just integrate. So for this one, it's gonna be integrate pi 6 to pi half. It's gonna be 9 sine square. Okay. And on the bottom, what do we get? We do get what? We do get 3 cos theta. Okay, so we do get 3 cos theta for the square root. So you see that this one, 3 cos theta, will cancel with cos theta on top. Okay, 3 and 3 cancel each other. So in this case, you get just d theta left. Okay, nothing left on the bottom. And you need to integrate sine square. Okay, so you need to integrate sine square. This is even power of sine theta. So you gonna use sine square theta, you change into double angle. So equal to 1 minus cos 2 theta over 2. Okay, so this one is going to be using the double angle. It's going to be the technique that we study in the 7.2 about the trig integral, first one. So for this one, you would just have integral pi 6 to pi half 9, and sine theta turn out, sine square theta turn out to be 1 minus cos 2 theta over 2 and d theta. Okay, so this guy will be 9 over 2, and you integrate pi 6 to pi over 2, pi over 6 to pi over 2. And this one will be 1 minus cos 2 theta d theta. Okay, and you're gonna have 9 over 2, and integrate 1, you get theta, integrate cos, you get psi, so it's gonna be psi 2 theta over 2 from pi 6 to pi over 2. Okay, and for this one, it's going to be 9 over 2. So it's going to be careful about this calculation a little bit, and I may run out of space here. So it's going to be psi, okay, so it's going to be pi over 4 over 2, that my first term, okay, and I'm gonna subtract 9 over 2, and it's gonna be pi 6, and it's turned out to be psi pi over 3 over 2, okay, and psi pi over 4 will be square root 2 over 2, and psi pi over 3 is square root 3 over 2, okay. So in this case, these two guys subtract each other. So you would get, let's use the green color. So you would get pi over 2, pi over 6 subtract each other. So you get pi over 3. So the final answer turned out to be, okay, 9 over 2 times pi over 3. This is the green color, okay, and you have this guy subtract this guy, so you have this guy subtract this guy, so it's gonna be psi, hey, it's 2 theta, it's 2 theta, it's 2 theta, so this one is not pi over 4, sorry, I make mistake here, so it's gonna be 2 theta, so it's gonna be psi pi. Sorry, it's going to be psi pi, and psi pi, the good news is it disappear, equal to 0, okay, and you end up with 9, okay, so this one is going to be plus 9 over 2 times root 3 over 4, okay, so that will be my final answer. Okay, so that will be positive at the end. Yeah, and it will be correct. Okay, so that. Okay, so it seems hard. I know it seems hard. I know. So like I told you, this one seems simple at the beginning because you not need to complete anything computer square. So you kind of chill for this one. However, at the end, it's kind of difficult calculation that you see. Okay. Okay, so let's do the last one. Okay, so the last one, you see that you not have square root. Okay, however, this one still the tricks up because you see x squared plus 4 squared. So you see x squared plus 4. Okay, so you see x squared plus 4. So you get this guy equal to u squared plus a squared. So you would have u equal to x and a equal to 2. Okay, u equal to x and a equal to 2. So you would substitute x equal to 2 tan theta. Okay, so you're gonna just have dx equal to dip tan, you get sec square theta d theta. Okay, so this one is kind of okay, right? So this one you see that you're gonna substitute x equal to 2 tan theta for sure, and you compute everything nicely. Okay, so let's plug everything in. Okay, so for this one, you're gonna just have 2 tan theta to the third plus 1 over, okay, so you have 2 tan theta to the third plus 1, and you have x squared, so you need to compute, let's compute x squared plus 4, so it's going to be 2 tan theta squared plus 4, so it's going to be 4 tan squared theta plus 4, so it's going to be 4, and you have tan squared theta plus 1, okay, and 10 squared plus 1 turned out to be sec square. Okay, so it's going to be secant square. So you get 4 secant square theta square, okay, and finally for dx, okay, for dx, so for dx you're gonna see that dx equal to 2 sec square, okay, so dx equal to 2 sec square, so you're gonna just write down 2 sec square theta d theta, so this guy is again, okay, so 2 sec theta d theta. So we have everything written down. Okay, so this one will be the thing that we shall have here. So in this case, let's simplify the top one. The top one, you would get integrate 8 tan cube theta plus 1 over, and you get 16 sec theta to the fourth. Okay, so you have sec theta to the fourth, and on top you get 2 sec square theta d theta, and you see that it's going to be, you get rid of this one and you have sec square theta on the bottom. So this allows you to conclude that you have 1/2, okay, so this one is your 8, okay, so this one, okay, be careful a little bit because we're gonna split this one. Let's get rid of 16 first. So for getting rid of 16, you get 16 and 2 that cancel each other, and try to put parentheses here so you're not gonna cancel your 8. So this one is gonna be your 8, right? So this one is gonna be 8. This one disappear. So you see that you're gonna split this one. Okay, so I'm gonna mention that I will split this one. I'm gonna split this one into 8 tan cube x, sorry, tan cube theta over 8, and you have sec square theta d theta. So that's my first term, and the second term is gonna be 1 over 8 sec square theta d theta. So you did split this one into 2 terms, and you're gonna get rid of 8. Okay, so this is how we obtain this one. So you see that we have to integral to integrate. The second one seems nicer, so let me call the first one, the second one respectively. So you have the first one, you have the second one. Okay, so you have the first one, the second one. And for the second one, let's do it here first. Okay, this one seems nicer, or I would say it easier. Okay, so for the second one, you get to integrate 1/8 outside, and you integrate 1 over 6 square. And 1 over 6 square is cos square. Okay, so it's cos square. And to integrate integrate cos square, this one change to double angle. Okay, so you use double angle. So you would get 1/8 and integrate 1 plus cos 2 theta over 2 d theta. So you're gonna just have 1/16 1 plus cos 2 theta d theta. So you get 1/16 theta plus integrate cos theta, you get sine 2 theta over 2. Okay, so this is what you get. And sine 2 theta, if you recall from your high school, this guy will be 2 sine theta cos theta. So that the trigonometry identity, and you'll be able to just get rid of 2 and 2. So this would allow you to get 1/16 theta plus sine times cosine. Okay, so that's my number 2. So this one will be 1/16 theta plus sine theta cos theta. Okay, so that's my number 2, ready for changing into x. Okay, so we have this number 2 ready. So for number 1, okay, I have another page here, so you may use other page. So for number 1, we must integrate. Let's use other color. So we must integrate tan to the third d theta over sec square. Okay, so you must integrate tan to the third theta over sec square. So for this guy, you're gonna try to use the technique that we study, and you see pretty clear that this one is odd power of 10. We recall the technique here. You have odd power of 10. When you have odd power of 10, you need sec theta, tan theta, d theta. And you will let u to be sec theta. Okay. In this case, I would say we're gonna let w to be sec theta. Okay, so this is the technique that we learned in 7.2, the second half. Okay, so for this one, you're gonna just write this one as 10 square times 10 theta. Okay, so you have 10 cube, so it's gonna be 10 square times 10 theta, and you need sec 10, so you're gonna multiply sec on top, you're gonna multiply sec on the bottom, and you still have 1 secant square on the bottom. So this is the yellow one. Let me highlight the yellow one. Okay. And the data still the data. Okay. With me so far? Okay. So for this one, we're gonna change everything in terms of W. So you get 10 square. Okay, so you get 10 square. 10 square here. 10 square. 10 square will be 6 square minus 1. 6 square minus 1. Okay, and you're gonna group 10 theta, sec theta. So this one I'm gonna highlight the purple guy. So the purple one turned out to be dw. So this guy turned out to be dw. This is the purple guy. Okay, because what? Because you see right in front of your eye here that you have dw equal to dipsec. Okay, and dipsec equal to sec theta tan theta d theta. Okay, so that my dw. Okay, so dipsec is sec10. Okay. So, and on the bottom, you would get sec to the third. Okay, so you have sec theta to the third, and you're gonna just have polynomial w square minus 1 over w to the third dw. Okay, and this one seems simple, so it's gonna be 1 over w. Let me split this one, so it's gonna be w square over w cubed minus 1 over w cubed dw. So you integrate 1 over w minus w to the minus 3 dw, and so this is it. So this guy will be just what? Log absolute w minus, it's going to be plus 1 over, not 1, w to the negative 2 over negative 2 minus I plus c. So it's going to be log absolute tan theta. Okay, so it's going to be log absolute, not tan, sec theta, w equal to sec theta. Okay, and it's going to be plus 1 over 2 sec square. So it's going to be 1 over 2 sec square, and then you plus c. Okay, so that is my one. Okay, so you see it's kind of long calculation here. And then what? And then we gonna just change everything in terms of x. Okay, so we're gonna change everything in terms of x. So this one, I'm gonna copy this solution down. I'm not gonna have 1 over 2 sec square. I'm gonna change this one to cosine square on top. Okay, so for this one, it's gonna be log absolute sec theta, okay, plus, okay, so plus cos square over 2. Okay, so this is how we have, so plus cos square theta over 2, and it's going to be plus 1 over 16, and they're going to plus c at the end here. Okay, so everything look nice so far. Good, right? So this one is number 1 and number 2 with different color. Let me change the color a little bit. So the green one turned out to be the green one, and the blue one turned out to be the blue one, respectively. And finally, you would like to change, right? You would like to change. So you have to concern above here, okay? So you would have x over 2 equal to tan theta. Okay, so x over 2 equal to tan theta. So you draw a right triangle. So you have theta. So you have x here, okay, opposite. And you have 2, which is adjacent. Okay, so you have 2, which is adjacent, and you have x squared plus 4 square root, okay, to be the hypotenuse. And now, using this triangle, you allow to change everything in terms of x. Okay, so you take a look at this triangle. So you think that you need to do is gonna be you're gonna just take a look at this triangle, and you gonna change this guy in terms of x. And also from this x over 2 equal to tan theta, Okay, let me move this guy a little bit further. Okay, so you be able to solve for theta. So you get theta will be, okay, so you allow to solve for theta from this one. So you allow to get theta equal to arctan of x over 2. Okay, so I like to have more space. Okay, let me enlarge it here. So you get theta equal to arctan x over 2. Okay, so this is all the thing that you need, and sometimes I need smaller x here. So you have theta equal to arctan x over 2. So this will be used for the pink guy. Okay, theta equal to arctan x over 2. Okay, so theta equal to arctan x over 2, that will be used. And the rest of the term will be from this triangle. What is sec theta? Sec will be hypotenuse over adjacent. So this one will be log absolute square root x squared plus 4 over 2. Okay, so that's my one term. And you have cos square, so it's gonna be 1/2, and you have cos, so it's gonna be adjacent over x squared square root x plus 4. Okay, and then use square. So this is the second term. Okay, the third term is 1/16. Okay, and you have theta equal to arctan x over 2. Okay, so you have theta equal to arctan x over 2. This is the pink term. Okay, and for sine and cosine, okay, so for sine and cosine, it's gonna turn out to be this yellow term. It's gonna be, you're gonna multiply two terms here, so you would get 2x over x squared plus 4, and finally you're gonna plus c. Okay, so you're gonna plus c, so this one is the yellow term. Okay, so sine and cos is gonna be 2x over x squared plus 4. Okay, why? Because you have x over square root and 2 over square root. When you multiply them, you're gonna just have 2x over x squared plus 4 from this orange triangle. Okay, so this is how we obtain the final answer. This one take longer than I expected. Okay, so this one is kind of more difficult. Okay, and you have two integral. Okay, and this one is the last example for this topic. Okay, so we're gonna continue next lecture on the partial fraction. Okay, so it's gonna be the rational function of the two polynomial that we gonna use partial fraction technique in order to integrate them. Okay, I can stop here and see you next time.